Today, we're going to write some code. And it might get a little messy, and you might wonder, how do we keep our code straightforward? One of the most basic design principles, not just in software, but in all of engineering, is KISS. Keep it simple. Simplicity, or the art of maximizing the amount of work not done, is essential. Using iteration and building the minimal documentation at the start of your projects helps your team avoid delivering unnecessary software. Let's start writing some code. We'll start by opening Eclipse. We'll accept the default workspace, and we're going to create a test project where we put our code, and we'll call this test project. And we'll call the class check number. All right. Next, let's write the code for the class. And in this case, we're going to start off working with if statements. And I've written some code, and I have it in the PDF file called Branches and Looping, which you can download. It'll save you time in typing. I'm going to paste that in. Notice that it is not well formed. So what we'll want to do is right-click on this, go down to Source, click on Format, and it cleaned it up for us. And the note that we would want to put some spaces in here as well. We can do that now. Make it a little bit easier to read. There we go, it's a little better. And this is a simple program to demonstrate the use of if statements. If we're going to run through this in the debugger, we'll place our breakpoint here on line 9. I'm going to go ahead and save, and I'm going to hit the debug menu option and confirm the perspective switch to debug. And there we go. It is positioned on the breakpoint on line 9. Started executing the program. I'm going to hit F6, and you can see that it's about to print. The number is positive. The number was initialized at 10. We can follow through in our code here. We can check the value of the variable number here in our variables section. You can see down in the console it printed it out as we expected. And then I'm going to hit F8 to go ahead and finish execution. And one thing to note then when using the debugger is we'll want to terminate this debug session. And we'll go to the window, perspective, and we'll go back to the Java perspective, and we'll modify our code. Going to change the 10 to an 11. I'm sorry, 10 to a negative 10 is what we want to test this time through. Save it. Run through the debugger again. Switch perspective. You can see it positioned. You can see that the value of the number variable is negative 10 this time. F6 to step through. And you can see that as expected, the if statement worked correctly. And then I'm going to hit F8 to finish execution. You can see negative 10 printed in the console. And I'm going to terminate the debug session. And perspective, going back to the Java perspective. So we've written a well-formed set of if and else statements. Next, we want to demonstrate the use of switch statements. So I will copy the code from the PDF file, and next we'll reformat it. So we go to Source, Format, and we'll put our spaces in to make it a little more readable. Takes just a second. right, and you can see I've indicated to place your breakpoint on line 11. We'll do that now. We'll save, run, switch to the debug perspective, and you can see that the variable number has been set to 10. We'll hit F6 to go through our switch statement. In case it is the number sign, in case it's 1, it's positive, as we would expect. Break exits out of the switch statement, and then we'll hit F8 to finish execution. And down in the console, as you would expect, it's printed 10 as positive. Now, we want to make this a negative, and we'll save. Need to terminate the previous debug session. We'll start a new debug session. This time, again, we've changed the integer to a negative, and we would expect it to print that it's negative. Should mention that one of the conventions we're using here is the sign num, which will return the sign of a number, and it's going to be -1 if it's positive. I'm sorry, -1 if it's negative, 1 if it's positive, and 0 if the integer is 0. So need to point out that that's really what we're using here is the test of our switch statement. But let's go ahead, let's continue. Now that we have it a negative and we've stopped, we can check the value. It's -10 as we would expect. Hitting F6, it is negative. Again, this is as would be expected. And the next statement is going to break out of the case. Hit F8 to finish. -10 is printed in the console. That's exactly what we expect. And I'm going to run through it one more time to test all 3 cases with the variable number initialized to 0. Let's go ahead and terminate the debug session, save the updated code, and we'll start another debug session. We can see that the variable number has been initialized to 0. And we would expect this to go down to the last case statement, which it did. Print 0 to the console, hit F8 to finish execution, and we'll terminate the debug session, and we'll return our perspective back to Java. And next, we're going to run a program that will include a random number generator. A little bit more complex. And this one will have an import statement. I'll go ahead and show you the PDF file. This is what I'm copying from. And the expectation is that it will not be formatted. We'll have to reformat it. Do that now. Right click, source, format, and we'll go ahead and put our spaces in for readability. All right. Now let's look at the logic behind this program. Notice that you've imported the random class. We're going to use a method from the random class to initialize a variable called random. It's a new random class object, and within the while loop, we're going to initialize an integer to the result of having run the next int method. A number between 1 and 100, put 101 in here. That's the upper bound of the random number generator. What it'll do is every time it runs, it will return a different number, somewhere between 0 and 100. And we're going to run through this 10 times, and it will give us a different number each time. They'll, again, random, as the name suggests. And we'll test that number, and if it's even, we'll print it's even. If it's odd, we'll print it's odd, and if it's 0, print it's 0. And the way that we'll determine that is by using the modulus. We'll divide it by 2, and as you know, any number divided by 2, if it has a remainder of 0, it's an even number. If the number is 0, well, obviously we'll just do that. So I should have said that first. And then we'll do the modulus. And if neither of those is true, then we assume it's odd and we print it's odd. Okay, we're going to run through this 10 times. I'm going to go ahead and put my breakpoint on line 20. And let's get started. Run the debugger. Switch perspective. And you can see that the number that random next int pulled back was 95. It's an odd number, so we would expect by hitting F6, it's going to go down to the last of the 3 sections. And it did. And we print generated number 95 as odd as we would expect. I'm going to hit F8. The next number is 31. Again, odd. We would expect it to execute this line of code, which it did. 31 is odd. Hitting F8 again. Here we have an even number, so we'll hit F6. We would expect it to execute this line of code, which it did. And I'm going to go ahead and finish running the program. Let's see. Control plus F11 will ignore debug the breakpoints and finish execution. And that way, we've you can see in the console, we've outputted 10 different numbers, 10 different tests of our if statement. And look, here's one that's 0, and the rest of them it's indicating whether it's even or odd. So our program worked as expected. Very good. All right, let's go ahead and switch back. Let's terminate these sessions. Don't want to leave too many open because they do consume memory and resources. And we'll go to the next program. And this one is a if statement, and it's revised to include a for loop. Replace our code, we'll reuse that. Again, source, format. And this one is a little different because when it hits 6, well, let me start from the beginning. For loops are done a little, they're formatted a little bit more complicated. The first section here initializes. We're going to use the variable int to test how many times to go through our loop. In this case, it's going to be 10. So as long as the int I is less than or equal to 10, we will continue processing. And at the end of every iteration of the for loop, we will increment the variable I by 1. And that is the logic that will cause us to go through the for loop 10 times. And I'm going to place my breakpoint here just before we print out the number. And then what we print out is, if it's even, again using modulus to divide by 2, and if the result is 0, we assume that the number is even. Otherwise, we print odd. With one exception, I wanted to show the use of, within a for loop, both continue, and then I'll recompile this with break, to show the two usages of continue and break within a for loop. So let's go ahead and get started. The first time through, we'll demonstrate continue, hit the debug. All right, you can see where I is equal to the value of 1. And we would expect that to be odd, hitting F6. Okay, as we would expect. Now I'm going to hit F8 to go through a little quicker. We don't have to go through every line. I just really want to increment up to the value of 6. So it's 3, 4, 5. Now we'll step through again, hitting F6. And you can see the continue. It skipped over. It didn't print anything that time. Continue again. There's the 6, I'm sorry. 7 would print, it's odd. And I'm going to hit F8 to go through it a little more quickly. 9 and 10. And there we've completed the program using continue. And next we'll use break. I'm going to drop this down to a new line, comment out continue, and we'll see what happens when I put break in instead of continue to test that. All right, let's clear the console. There we go. Sorry about that. Now we'll hit debug, and you can see its int is I, and I'm going to hit F8 because really we're only interested in seeing 6. We know that the rest of the logic works correctly. We just want to demonstrate break. 2, 3. I'm hitting F8, F8, 4, F8, 5, F8 again. Now it's 6. We'll drop into the code using F6 to go line by line. Okay. And here's our break. And break exits out of the for loop. So you can see with continue, it jumps out of the logic, irregardless of what the value is. But with break, it jumps out of the for loop. And in this case, it's going to hit Control F11 to finish the program, and it's done. Again, cleaning up, we're going to terminate the debug sessions. We'll go back to the Java perspective where we can continue writing code. That is all I have for today. Thank you, and we will talk again next time. Bye-bye.